You know that feeling, right? You're following a tutorial, step by step, everything's going great, and then, bam, the last command fails. Something changed, and nobody bothered to update the guide. It is one of the most maddening things in tech. Well, today, we're going to look at an AI-powered system that's designed to fight that exact problem and keep technical docs totally in sync with the code they're supposed to describe. Okay, let's dive in. I mean, it's a question we've all screamed at our monitors, right? The software gets an update, the API changes, maybe a file just gets moved, and suddenly that perfect guide you were following is now a landmine. And look, it's not really anyone's fault. It's just a natural side effect of making things better. But what if we could automate the fix? So that brings us to our first section here, the documentation dilemma. This is all about really digging into the core problem we're trying to crack.
There's actually an official term for this, and it's documentation rot. I love that term because rot just perfectly nails what's going on. It's this slow, natural decay. As developers are busy innovating and improving the code, the docs get left behind. Over time, they get less and less accurate until eventually they're not just unhelpful, they're actively misleading you.
So how in the world do you fight something like that? Well, the solution we're looking at today is a system that basically acts like an AI code librarian. And its whole job, its only job, is to read through the entire library of documents and make sure they actually match the reality of the code on the shelves.
So here's the game plan for our little librarian. First up, discovery. It just goes out and finds every single documentation file it can. Then, classification. The AI reads each one and decides, okay, is this high priority, like a setup guide, or low priority, like some old meeting notes? After that, it does some batching, grouping similar files together to be more efficient. And then we get to the magic step, verification. This is where the AI literally reads the source code to check if the instructions in the docs are still true. Finally, it bundles up all its suggested fixes into a pull request, complete with evidence for every single change so a human can give that final thumbs up. But, getting this whole pipeline to actually work, well, that revealed something totally fascinating and unexpected about how these AI models think. And that brings us to what I'm calling the multitasking mistake. So, the first attempt was pretty straightforward. Just give the AI a document and a big checklist. Hey, check the links, verify the commands, fix the formatting, do it all in one pass. Simple, right? Except it didn't work at all. The AI's performance was just terrible. It was missing super obvious errors, making new mistakes. It was acting, for lack of a better word, overwhelmed. And what's so cool is that there's actually a scientific name for this: task interference. There's real research on this, including a study from MNLP 2024 showing that when you ask a large language model to juggle too many different kinds of tasks at the same time, its performance just tanks. It's almost exactly like human cognitive overload when we try to multitask. So the big unlock, the key, was to just stop asking the AI to multitask. Instead of that one huge, messy request, they broke the job down into 3 super focused passes. First pass, check only the links, nothing else. Second pass, look only at the commands and processes. And a final third pass just for cross-references and formatting. By giving the AI one single job to focus on at a time, its accuracy and the quality of its work just shot through the roof. And this whole discovery, it really points to a much bigger idea about how we should be building AI tools. It's not about making the AI do everything. It's about creating a really smart partnership between the AI and good old-fashioned code.
Which leads to this brilliant design philosophy: maximize AI value, minimize AI usage. Now, that might sound a little contradictory, but it's absolutely the key here. The idea is you only use the expensive, powerful, and let's be honest, sometimes unpredictable AI for the things that only it can do. Those tasks that require a real understanding of meaning and context.
Let's break down how that actually plays out. The AI, that's your semantic brain. It's doing the really tough stuff, like figuring out if a link is not just working, but actually relevant, or checking if a command in a tutorial actually matches what's in the code base. Meanwhile, regular code is your reliable worker. It handles all the grunt work, the mechanical stuff, finding files, sorting them into batches, running Git commands, and building that final pull request. Code is perfect for any job that has a clear, repeatable recipe.
And wow, does this partnership work? Code is way faster and basically free for these simple tasks. And by saving the AI for just the complex stuff, you avoid the risk of it hallucinating or making a weird mistake on a simple job like finding a file. And the result of this smart division of labor? Get this, a massive 60% cost reduction compared to a naive approach where you just throw the AI at the whole problem.
Okay, so the theory is really smart. It all sounds good. But what about the real-world results? Let's take a look at how this system actually performs when the rubber meets the road.
All right, let's talk brass tacks, the cost. Using this smart, balanced approach, the system can process and verify 100 documentation files for about $39. All of a sudden, keeping your docs up to date goes from being this impossible, never-ending chore to a totally affordable, automated task. That's a game changer. Now this chart right here, this is the hard data that proves that whole task interference theory we talked about. Look at this. When processing docs in small, focused batches of 5, the system successfully updated 91% of them. That's amazing. But see what happens when you double the batch size to 10 to try and speed things up? The AI gets overwhelmed, and the coverage absolutely plummets to 64%. This is the trade-off in action. Smaller batches might be a little slower, but they deliver dramatically higher quality. So let's sum it all up. With the optimal setup, you're getting 91% of your files updated, and it takes about 3 hours per 100 files. But the most crucial part is this principle. The system is preservation first. It's incredibly conservative. It will not suggest a change unless it can find cold, hard proof in the source code. This is how you build trust and make sure the AI is actually helping, not just making a mess.
And that kind of leaves us with one big final thought. The huge lesson here isn't just about documentation. It's about a fundamental principle for working with AI right now. If giving an AI a single, focused task is so much more effective than asking it to multitask, what does that mean for how we should be designing our own AI-powered tools? It suggests that maybe we should start treating AI less like a single, all-knowing assistant and more like a team of brilliant but very, very easily distracted specialists.